All right, in this example, we're going to look at some conceptual curve sketching. So this is a problem where a calculator is not going to help us. We really need to understand the rules for monotonicity, where the graph is increasing and decreasing, and how that might create a maximum or a minimum, as well as our rules for points of inflection and concavity, which come from the second derivative. All right, so here we're going to sketch the twice differentiable function y equals f of x. And that just means that the function is something that we could differentiate twice. We can take the derivative of twice. So it's probably a polynomial because polynomials are infinitely differentiable and they're easy to deal with. And this is just a possible idea of what the function might look like. All right, so it's going to pass through these 5 given points, -3, -2, -2, 0, 0, 1, 1, 2, and 2, 3. So let's focus on what we know about the first derivative here. Now, a negative first derivative means we are going to be decreasing. And a positive first derivative means we're going to be increasing. And so we're increasing all the way between -3 and 2 because the derivative, the first derivative, is positive between -3 and 2. And then after 2, we have a negative first derivative, which means we're going down again. So if we have to make a conclusion about where there might be a max or a min on this graph, we would look at -3, and since we are going down and then back up, we're going to assume there's a minimum at x equals -3. Similarly, because we have a sign change from at the critical point x equals 2, we're going up and then back down, there's going to be a max at x equals 2. All right, so we've got information about increasing and decreasing and maxes and mins. Let's look at the second derivative portion of this graph. All right, so second derivative tells us about concavity. Second derivative, those values when we set it equal to 0, represent possible points of inflection. If the second derivative is positive, we've got concave up. Now, when we think about this, I'm going to go through and just say concave up, concave down, and then we're going to think about how the monotonicity, how the increasing and decreasing affect that concavity. Because remember, when we sketch concavity, we're only going to sketch the left or the right half of the concave up or the concave down. So green is concave up. I'm just going to write that twice because I'm going to draw a little line here. And red, this negative region, where the second derivative is negative, we know our graph is going to be concave down. And then when we look at between 0 and 1, the second derivative is positive, so we'll say concave up. And then looking at greater than 1, we have concave down. I'm going to write that twice just for what we're going to be talking about here when we extend our thought process. So looking at this, I'm going to kind of draw some vertical lines to help us with that table like we did in class. You might not be able to see that one. Let's make it a little darker. A vertical line here, and I'm going to draw these vertical lines to kind of pull what we're talking about at these points of inflection and also considering this concavity as well. All right, so I've got these vertical lines. I've broken these into number lines that work together. So just in this first region, right in here, in this region, we are decreasing and concave up. So we have this half, the left half of our concave up curve is where we are decreasing, and then when we reach the bottom of that concave up, it turns around and starts going up. So if you look on the right side of x equals -3, still before -2, we have increasing concave up. So increasing concave up looks like that. Now, at x equals -2, we have another change. We are increasing, and then we are concave down. So what does increasing concave down look like? It's the right half of concave, I'm sorry, the left half of concave down. All right? Now what's happening in our region here, right here, where my x values are greater than 0, but less than 1. So between 0 and 1, we have concave up, and we have concave up increasing. So concave up increasing looks like this. Between 1 and 2, in this region that we, oh goodness, in this region that we see right here, between 1 and 2, we are increasing and concave down. So increasing and concave down, what does that look like? We've got this piece of a curve. And then our last region here, this region, when we are greater than 2, you'll see the graph is decreasing and concave down. So what does decreasing concave down look like? It's the other half of that curve. We've got decreasing concave down. All right? So where the concavity changes, in these changes, when we change from concave up to concave down, those represent inflection points. All right? So if you notice at x equals -2, right here on this line, at x equals -2, we have a change in concavity. So this is a point of inflection right here. We've got inflection happening there. We also have inflection because we change from concave down to concave up at x equals 0, and we have inflection at x equals 1. All right? So we have 3 inflection points. We have 1 minimum and 1 maximum. Now, my handwriting looks a little messy, so I'm going to kind of erase these inflection values there. Well, that's terrible. Let's do that. There we go. All right. One more. Take that out of there. So I'm just going to write an I to represent inflection. Inflection, inflection, inflection. That will make it look not so messy. All right, so from here, we need to sketch our graph. When we sketch these graphs, we do not have to sketch the y-axis perfectly to scale. So I'm going to draw a number line here, and I'm going to plot, you know, at least out -3 on the x-axis and then forward to +2. So I'm just going to kind of draw a vertical line here. We're going to go out 1, 2, 3, 4. That's x equals -4. And we're going to go out 1, 2. All right. Do not worry about scaling your y-axis appropriately because that's not always going to make sense within the context of the graph. Here's what we want to sketch, though. We have a couple of points. I'm going to plot those, and these are all reasonable. I've got -3, -2, and since they're reasonable, I'll put some points on here because I think they're all within 2 units. So -3, -2, here's one of our points that was given. Let's see what else we have. We have -2, 0, so over 2, 0. And then we have 0, 1, so over 0, up 1 is right here. And over 1, up 2. Over 2, up 3. Looks like I should have. Let me adjust this just a little bit. Boop, boop. Drag that down. I'll give myself an x equals 3 over here. So I said over 2, up 3. Okay, so these points that I've plotted, these are all going to represent points on the graph. Now, all we have to do is think about what the graph is doing. So as we approach -3, this point right here, as I approach -3 from the left side, the graph is concave up, decreasing. So we're going to see this sort of curve. We don't know what the 0 is. We just know the graph is going down and approaching that point. And when we reach that point, we said, hey, that's going to represent some sort of minimum. And the graph is going to have to turn around. So you'll notice, looking right here, once we reached -3, we hit that minimum, the graph turns around and we're concave up, increasing until we get to our point at -2. So concave up, increasing at x equals -2 right here. You notice after -2 until we get to 0, we are concave down, increasing. So sketch like that, concave down, increasing. Between 0 and 1, we are concave up, increasing. Between 1 and 2, we are concave down, increasing. And then once we get to x equals 2, we are concave down, decreasing. So concave down, decreasing is going to create something that looks like this. And what you notice is we said we were going to have a max over here at x equals +2. All right? So, you know, all of these little gestures together, I'm going to come in here and use like a highlighter, they make a curve that sort of goes this all together. We've got those two pieces. That is the shape of our curve, and that's the best we can do with the information given. The point is that we really want to make sure we understand how concavity works. I hope that helps. Please email me if you have any questions or concerns.